so today we have what we call science. This is chapter 8, and the topic is about metals and non-metals. Okay? Metals and non-metals. So at the end of this chapter, these are the following things we are expected to understand. First, we're supposed to be able to identify metals and mixtures of metals. So we should be able to identify metals at the end of these chapters and the mixtures of metals. Then we should be able to describe how the arrangement of atoms in metals give them specific property that they each have. Okay? Then we should be able to link the properties of metals to their uses. We should be able to link their property to their uses. We should be able to describe how the arrangements of atoms in non-metals make them different to metals. So the arrangement of non-metals, how the arrangement make them different from metals. Then we should be able to also name some solids and gaseous non-metals and their uses. We should be able to state their uses. So now let's take a look at what we have first, the metals and their properties. The metals and their property. If you take a look at the periodic table, you see that most of the elements in the periodic tables are metals. Most of the elements in the periodic tables are metals. Now, apart from mercury, all metals are solid at their room temperature. The only metal that is not solid at room temperature is mercury. Okay? Every other metals at room temperature, it's a solid. Mercury is the only metal that is not solid at room temperature. Is that okay? Now, again, some of the metals that we have or we have seen in the periodic tables, or that we include or that we use, that we are familiar with, are one, iron. We're very familiar with iron. Okay, iron, we're very familiar with it. Tin is a metal. Zinc is a metal. Aluminium is a metal. Copper is a metal. Silver is a metal. Even gold is a metal. Mercury is a metal, despite it is not a solid at room temperature. Mercury is a metal. Lead is a metal. Chromium is a metal, and so on and so forth. Okay? Okay, we have more. We have, apart from the transition metals, we have the group 1 metals and the group 2 metals. Where we start, group 1 metal, we mention sodium, we mention lithium. Okay? We measure lithium, we measure sodium, we measure potassium, and so on and so forth. These are group 1 metals. Then the group 2 metals, we talk about, group 2 metals, we'll be talking about magnesium, you know. We mention metals like beryllium, magnesium. Okay, so these are group 2 metals. Then, after group 1 in the periodic table and group 2 in the periodic table, the next metals that we have, they're called the transition metals. There are a lot of metals that are called transition metals. We're going to look at them. Okay, so these are some of the metals. There are still more, like calcium, with, as we said, potassium, magnesium, like the group 1 and group 2 metals. The alkali earth metal and the alkali metals, the group 1 and group 2 metals. Okay, these metals are only found in nature as part of a compound, like the group 1 and group 2 metals. They are not found alone. They are found in nature as part of a compound. We extract them from compound. We extract them from compound. We extract them from compound. Is that okay? So these group 1, group 2 metals, they are not found alone. We extract them from compound. Now let's talk about alloys. Alloy is a mixture of more than one metal. Like we take 2 or 3 or 4 metals, you blend them together, it becomes an alloy. So an alloy is a mixture of more than one metal. A mixture of more than one metal. Alloys have similar properties to pure metals as well. They have similar properties to pure. For example, let's take a look at some alloy. Brass. Brass is an alloy. And it's an alloy that is made up of copper and zinc. Brass is an alloy that is made up of copper and zinc. I think we need to demonstrate each of these, and maybe probably we can give their symbols, okay, as it were. Now let's go to our board. Let's take a look at brass. Okay, we say brass. Brass. Brass is an alloy, right? We measure the alloy, then we can measure the element. This is an alloy. Okay, we can make it like a table. This is an alloy. and then we look at the elements that are found in each of the alloy. So let's mention the element. Brass is made up of or we can use table. Okay, we already draw this one. Number 1, brass. Brass is made up of what? What is brass made up of?
Copper and
copper and zinc. Yeah. Is that what brass is made up of? We say brass is made up of what? It's an alloy of what? Copper and zinc. So we can use symbols, right? So copper, I just use Cu for copper. And then this and zinc. Zn, right? The symbol for zinc. Okay, then another alloy of metal is called bronze. Have you heard of bronze? Bronze is another alloy of metal. Bronze. Okay, now which elements is bronze made up of? It's made up of copper and tin. Ze. Bronze is made up of copper and tin. Copper is Cu and tin is what? Sn, right? Tin is Sn, right? Okay, number 3, another alloy of metal is what? Solder. Another alloy of metal is solder. Solder is made up of what? Solder is made up of which element? Solder is an alloy of tin and lead. Tin is Sn there, and lead. Lead is Pb, the symbol. Please know the symbols of elements, okay? Then another alloy of metal is what? Another alloy of metal is steel. Steel is an alloy that is made up of up to three elements. Made up of up to 3 elements. Steel is another alloy. Now let's list the elements that steel is made up of. Steel is an alloy of iron with carbon and other elements. Iron is Fe, right? Iron is Fe, the symbol. Iron, carbon, and others. And other elements. Things like zinc also. Okay, and others. Okay, so now the elements that is combined with iron gives the steel their different properties. The element that combines with iron gives the steel that specific property it has. For example, chromium and iron give a stainless steel. So if you want like a stainless steel, you can have, for example, stainless. If you want a stainless steel. If you want a stainless steel, then you need chromium with iron. Chromium to combine with iron. Chromium plus iron. Iron is Fe, chromium is Cr. Okay, so you need this to combine with chromium. Chromium and iron gives us a stainless steel. Tungsten and iron mix to give us to make a tool steel. Like you have what we call the tool steel. Steel for making tools for work, engineering work. Tool steel, you use what? Tungsten. This alloy of metal, tool steel, you use tungsten and iron. Tungsten, you blend tungsten. Okay? Toxti plus iron together plus iron. Then you make it a two steel, a very strong metal for alloys of metal for use in engineering work. Okay, so if you want two steel, you need a toxti mixed with iron. Okay, toxti and iron, when they mix together, they can create what we call the two steel, because toxti has a very high melting point of any metal, and it melts about 3,410. The melting point of this one is very high, toxti, about 3,410 degrees Celsius. Okay, this is the melting point. Melting point, MP of toxti is about 3,410. So it's very high. So it gives it helps you to create very strong metals. Okay, now let's move on to the next one. Let's move on to the next phase. Let's move on to the class. Okay. So you have some questions. How many different metals did you identify? And what is the most commonly used type of metal? Iron, right? One of the most commonly used type of metal is iron, right? How many of these metals on your list are elements? How many of them are elements? So the metals you have on your list, especially the traditional metals, if you look at group 1, group 2, they are found in compound. We extracted from compound. Now let's go to the chemical properties of metals. Let's take a look at the chemical properties of metals, right? Now, you know an atom has a nucleus, and the nucleus has fixed number of protons and neutrons. Protons, they're the one that have the positive charge, right? While the electron has the negative charge, the electrons that revolve. The neutrons, they do not have charge, they're neutral, so they don't have charge. So the core is surrounded by a cloud of electrons which are negatively charged and which move around in the empty space around the nucleus of the atom. Now the number of electrons in an atom is equal to the number of protons. Electrons and protons are same. That's why we say an atom is electrically neutral. So number of electrons is equal to the number of protons. So we can simply say an atom is said to be electrically neutral. But it is the electron that is responsible for the chemical properties of atoms or of metals. The electrons contribute to the chemical properties. Okay, electrons attributes to the chemical properties of atoms or of metals. Okay. Now the way in which atoms are arranged in metals is what makes them different from their non-metal counterparts. Okay, and gives them their physical characteristics, the way they are arranged. Now let's take a look at the arrangement of atoms in a metal. Let's take a look at them. Now the arrangement of atoms in metal allow electrons to associate freely with different atoms. So we say the electrons are free to move. Look at it. The electrons are the one with the negative. They're free to move in a metal. Okay, you can see they have an arrow. All the electrons, all the negative, they carry an arrow, meaning they're free to move. The positives are the protons. They are fixed in the nucleus. They don't move. But the electrons, they have arrows, showing that they are free to move. Showing that they are free to move. The positive is the nucleus of the atom. Every positive you see is the nucleus of an atom, because it's the only proton that is positive in the nucleus. The neutron does not have a charge. So the plus represents the proton, and it symbolizes the nucleus of an atom. The electrons revolve around it, they move around it. These electrons, they move around the nucleus of the atom. So this is a simple representation of a metal. Now let's talk about conductivities in metal. We say conductivity, the fact that electrons can move freely from one metal atoms to another, means that the metals are good conductors of electricity and also good conductor of heat. So these electrons, because the fact that they can move freely from one place to another, it shows that wired metals are good conductors of electricity, meaning current can flow, electrons can move. You know, once electron is in motion, electricity is already produced. So metals are good conductors because they can carry the charged particle from one place to another. They can carry the charged particles from one place to another. So metals are good conductors. This is a good example of a metal. This plastic covering it is an insulator covering the real metal inside. The metal, this is the conductor. It carries electricity and can conduct heat as well. Now this is what it is. If you connect, let's say this is a piece of metal. If you connect it to a battery, you can see the electron will start to move. The electrons start to move. The big plus is the nucleus of the atom. The electrons start to move. They start to move and flow from the negative side towards the positive. The electrons flow from the negative. You know, this is the negative side. The electrons will flow. You see the arrow, they are pointing to this way. They are coming from the negative. This is the negative way. This way is the negative side. So they're flowing to the positive. So the flow of electron will continue until you stop the battery, you remove the battery. As long as this battery is still here, the electron will continue to flow like this, okay? Flow from this negative side to the positive and continues like that in a continuous process. Now this is a metal, like a nail. If you hit it, becomes red hot, it can conduct. If you hit this top, the heat will transfer across it to even the bottom. So if you touch the bottom, it will burn your hand, even if you didn't put the bottom on the fire. So it's only the top here you put on the fire. You see, everywhere is hot. The heat is being transferred because a metal is a good conductor of heat and electricity. Every metal is a good conductor of heat and electricity. Are you with me? Every metal is a good conductor of heat and electricity. Now you can see some of the properties of metal. They are malleable. Metals are malleable. What's the meaning of malleability? When we say metals are malleable, what do we mean? When we say metals are malleable, what do we mean? They are malleable. That means they can be beaten to different shape. They can be beaten to different shape. You can.
You mean what?
Malleable.
Oh.
They are malleable.
Okay.
Yeah, they can be beaten to different shape.
Okay.
Yeah, you see, you hit it. You hit this metal. You can now use a hammer to bend it, to bend any shape or flatten it. If you want it to flatten it, we flatten. So you can hit it and beat it to different shape. Ductile. When you say metals are ductile, meaning they can be drawn into wires. Metals can be heated up and drawn into wires. Okay, you can draw them into wires. Okay, okay. You can bend them into different shape. That's malleability, and pull into wire. That's ductility. Metal also behave like this because the atoms can be rearranged into new shapes without affecting the electrons. Metals can behave like this because the atoms can be arranged in a new shape without affecting the electron. The electrons simply flow into the new shape that you have bent the metal into. Okay. We also say metals are shiny. One of the properties of metals is that they are shiny. This is because the electrons absorb light energy as they move and they release it again. Okay. Okay. So this is the first part of today's class. Now we're going to take metal again in another format. We're going to take it again in another format. This is the first part. Okay. Thank you very much. Thank you very, very much for joining.